Good day for everyone. In this exercise, we will explore how to model hydrogen pathways using OSeMOSYS. The first step is to go to this nodal repository. The link to the repository is provided in the description of this video. Please download all the files that you can find here and save them in a separated folder, including the OSeMOSYS code cloud, and also create 3 new folders for saving the information that we are going to model in this exercise. First, we will open the hands-on hydrogen osmosis file, which is this. And in the first part, you can find a brief introduction with some concepts of hydrogen and also the policy context that is involved with this exercise. Now, let's go with the process of modeling. This is the energy subsystem that we want to model. It has two electrolyzers, one that is connected directly to the power grid and another one that is connected to a dedicated solar power unit. And also we have the steam methane reforming plant to produce hydrogen using natural gas. It means that we will need to create 4 new technologies, one for the dedicated solar power plant, 2 for the different electrolyzers, and another one for the steam methane reformer. And in addition, 2 new fuels. The first one, electricity produced from the dedicated units, and also the hydrogen as such. Now, to create this, we are going to follow the instructions. The first one is just to go to our file, that is the baseline case file that you can find also in the repository. You are going to look for the first cell that you can have this predefined naming, and you are going to change it. In this case would be power source 003, that is our dedicated unit, in this case dedicated solar power unit. And then we can create the other ones, which are the electrolyzers. In this case, the first one, that is the electrolyzer connected to power grid. And the other one, that is the electrolyzer connected to the power dedicated unit. And finally, we have the steam methane reforming plant. This one over here. So this is our SMR plant created. Yes, so this is the way to create new technologies, and also we will need to create new fuels. That is, in the case, we are going to look for the first predefined naming that we can find, that is COM013, and we are going to change it LCH2 for electricity for hydrogen production in this case. And also we can create the other one, that is HDG001, which is hydrogen, essentially. Okay, perfect. So that is the first instruction that we need to follow to create the technologies, also to create the commodities or the fuels. And now we are going to include the energy demand for hydrogen. So here we are going to follow the instructions again. Please go to the file that is called data preparation file, which you can find also in the Senado repository. In my case, it is over here. So we can open it. Then we are going to the first tab, that is the demand, and we are going to copy and paste the values that we have in this case until 2050. Then we go to parameters, and in this case it's an accumulated annual demand. So we can select it over here, just like this one. And we are going to select also our hydrogen 001 in this case. So this is the demand that we need to satisfy as indicated in our file. So we have accumulated annual demand and HDG001. So we can go again copy our data for the demand, then go over here, copy and paste it. Okay, so this is the first part, including the annual demand for hydrogen. Then we can also save our file just to make sure that all the data is safe. Now we can continue with the creation of the input and output activity ratios. So here we need to follow the instructions once again. For this case, we will start with the input activity ratio. So in this case, what do we have to do? Go to the file. In this case, we are going to select, okay, first, and filter this. We are going to select the input activity ratio in this case. This is our input activity ratio. Now we are going to filter our technologies, which are the solar dedicated unit, the steam methane reforming, and the electrolyzers. And also we will select the different fuels which are input fuels for those technologies. So let's check it. After selecting input activity ratio, we are going to select here technologies that are involved in our case, which are the power solar 003, and also the electrolyzers that are UPS. And here we will need to select the fuels that we want to analyze. In this case, they will be electricity 003, electricity for hydrogen production, and also natural gas. Let's check if we have everyone there, all of them there. So we have solar, natural gas, okay. Solar is missing. So go ahead. L003, LH2, hydrogen, and finally solar. In this case. So here, for the solar unit, the input fuel is sol, so this will be 1 for all the years until 2050. Over here. Perfect. Now, for the electrolyzers, the input fuel is, in fact, it depends on the electrolyzer. For the first electrolyzer, the input would be electricity 003, which is the electricity which comes from the power grid. So here we need to take into account the efficiency for the electrolyzer. So in this case, we know that is 1.5 over here, as you can see. So we will change it. Okay, perfect. Then you get a spirit. Then you are done. Then for the other electrolyzer, the electrolyzer number 2, the input fuel is the electricity for hydrogen production. So in this case, we use the same value, but the input would be the other electricity. We spread it. Okay, and finally, for the steam methane reformer, the input fuel is natural gas, which is missed here. So just let's go back and select natural gas like this, and the value that we need to type would be 1.5 0.41. So here we can change the value and spread it. Okay, perfect. So that would be our inclusion of the input activity ratio. The next step would be to modify the output activity ratio for our technologies. As you can see here, in this case there will be the electricity for hydrogen production, in this case for the dedicated unit, and also hydrogen for the rest of the technologies because they are producing hydrogen, and for all of them the value of the output activity ratio will be 1. So let's come back to our SAN file. We are going to select the output activity ratio in this case. We already have our technology selected, but the difference is that we're going to filter just the electricity for hydrogen production and also hydrogen. So this and this, as you can see. Okay. Once this is done, we know that the dedicated unit is producing electricity for hydrogen production. So we use 1 over here. You can extend it. Also, as this is the same, we are going to copy. We have to copy all the values right here. We also know that the output for the electrolyzer is hydrogen. So copy. The other electrolyzer is also hydrogen. And finally, the steam methane reformer is also hydrogen. So after that, we have changed all the output activity ratios for our technologies as indicated in our document. Like this, you can always verify that the figure matches what you have in your file. Now we are going to include the cost, capital, fixed, and variable costs for our technologies. However, in the case of variable, the values are 0, so they are not going to change. So in this case, we are going to open again our file of the data preparation. We are going to check for the capital cost, as you can see here. Let's go for the SAM file. We are going to unfilter like this. And we already have our technology selected, so we just need to change the parameter that we want to analyze, that in case is capital cost first. And in this case, you have these values. So essentially, we are going to copy all the values and then paste it like this. Perfect. We will repeat the process with the fixed cost. It's over here. We come back to our tab. This is the fixed cost. Select, copy, and paste it again. Like this. Okay, perfect. Now, let's check what we have here. The variable cost is still missing. So variable cost is 0 essentially. Before selecting, we are going to filter the variable cost over here. We are going to change it by 0. Okay, perfect. Now, let's continue with the instructions. One important thing is to change the capacity to activity unit parameter. So in this case, we are going to repeat the process. We just need to filter by the capacity to activity unit like this. Select the other one, and we are going to change this value over here, 31,536. This is the factor of conversion from gigawatts to petajoules per year. So we are done with this part now. The next part is the capacity factors. So here we need to do the same, but in this case we are going to select the capacity factor parameter and select capacity factor. Now it's over here. Now we can go to our tab, and here we have all the values that we need. Just copy, and you can paste it over here. Right. So this would be our capacity factors. Just check that all the values are along the way. It is working properly. So this would be the inclusion of the capacity factors using our data preparation file. And now we will include the residual capacities also using the data in our file. So let's go to the baseline case and filter capacity factor and select the residual capacity one like this. And we are going to our data preparation file, and you have the tab for the residual capacity, that as in this case is just for the steam methane reformer. So go back here, and you can complete it over here, just for the steam methane reformer. Okay, so perfect. We are done over here. Now, using the operational lives, as you can see here, it will be 25 for all the technologies. So again, we can select the operational life parameter and select residual capacity. And we will change this value of 1 by 25. The same for all the technologies. Perfect. Let's save it. Let's take a look to the next instruction. So we are done finally with the inclusion and modification of our baseline file. So after saving it, you will have the BAO scenario, because we are not going to include any other modifications. So in this case you can save it, and you can change the name to BAO, and you can save it in the corresponding folder in your computer. So here we have the BAO scenario, that is the same scenario that we just finished. So this baseline with these changes that we made represents the BAO scenario. We don't need to do any other modification. So this is our first scenario. After doing that, we need to use our ClickSend. So in this case we can select, just for showing you how it would work, we can do here our folder with the BAO scenario. We can select our file, as in this case is the BAO1. Then in this button we select the OSeMOSYS code cloud file, that is this one, and then we can run the model. Yes, after doing that we will get the corresponding results for that scenario. That is the step that we will need to do. Now let's go with the second scenario, that is the energy security scenario. In this case what we need to do is basically go to the BAO scenario, copy this file, and then paste it in our folder of the energy security scenario, and just change the name as this one. And we are going to do the modification. What is the modification that we will need to do? Just for your notice, is over here. So according to our file, here we're going to include the natural gas reserves using the parameter of total technology period activity upper limit, and also we are going to modify this for the reserves using the mining natural gas technology, and also setting the imports of natural gas equal to 0. So here we can open this. We're going to select all the technologies first. Now here we were going to change the parameter. It is not operational life anymore. We are going to select the total technology model period activity upper limit is this one, and we are going to select the two technologies that we discussed before. So here we have imports of natural gas, but we also have mining of natural gas or extraction of natural gas. There are other technologies over here. So for the first one, that is the mining, the extraction, the domestic production of natural gas, we are going to change the value by 350, and the other one for the imports would be set in 0. Okay, that's it. You can check the values over here just to make yourself clear, and then you can save it. And after save this file, you will have the energy security scenario. You can save it into the corresponding folder and repeat the process and run this scenario using the ClickSun offline. That is the second scenario that we have. Now, we need to make another copy of the BAO scenario, which would be our third scenario, the green policy scenario, which is the third one. It's over here. So what is the difference between the green policy scenario and the BAO scenario? It is that we're going to include a carbon budget to achieve net zero emissions by 2050. So in this case, we are going to check our data preparation, and in the final tab you will find the carbon budget for your model. So you can copy, you can go to your green policy scenario file, take into account that this is another copy of the BAO scenario, and what you are going to do is that you are going to look for the emission Okay, let's check the name. Okay, we need to select these values first. In this case, don't forget that our parameter is the annual emission limit. So we need to go here. Now we are going to select the annual emission limit. Is this one. And for the first one, that is the CO2 emissions, we are going to copy and paste the series from our data preparation file. Go over here and copy. And now we have our carbon budget for this scenario. So you have to save it, and you will have the third scenario for your modeling. So after doing that, please save the scenario, open ClickSun once again, select that file, select the OSeMOSYS code cloud file, and run the third scenario. After doing that, you will have all the results for the business as usual scenario, the energy security scenario, and also the green policy scenario. After doing that, you can use the last file of our Senado repository, which is the visualization dashboard template. So here you can copy and paste all the data of your three scenarios and do the corresponding process for visualizing the results. You can find a video for this specific target in our repository on YouTube too. And after doing that, everything will be done. That's everything for our exercise. You can also find here some reference results that would be the ones that you can get using the visualization template, and some discussion questions for you to analyze what we can conclude from the whole process. And that's it. Thank you so much for your attention.